Good morning, everyone. In the last session, we had discussed about the transfer of heat. There are three ways of transfer of heat. They are conduction, convection, and radiation. Today in this session, we are going to discuss about blowing of sea breeze and land breeze. Gentle wind is called breeze. The people living in coastal areas, that is seaside areas, experience interesting phenomena called sea breeze and land breeze, which are based on the transfer of heat in air by convection currents. Now, what is the reason behind it? Children, we know during daytime, when the sun shines, the solid land gets heated to a higher temperature much more quickly than liquid seawater. The hot air over the land rises upwards and cooler air from over the sea moves towards the land in the form of a cool breeze. The breeze blowing from the sea towards the land is called sea breeze. The cool sea breeze blows only during the daytime when the land is hotter than the sea. To receive the cool sea breeze during the day, the windows of houses in coastal areas are made to face the sea. At night time, the hot land cools much faster than the warm sea water. Due to this, the land becomes cool very quickly, but the sea water remains warm for a much longer time. So during night, the hot air over the warm sea rises upwards and cooler air from the land blows in towards the sea in the form of a breeze to take the place of hot rising air. You can see in the figure on your screen the breeze blowing from the land towards the sea is called land breeze. Land breeze blow only during the night when the sea water is hotter than the land. Then next, radiation. When we switch on an electric bulb, it becomes hot and gives out heat and light. Now, if we keep our hand a short distance below the glowing bulb, we can feel its heat on the hand. This means that the hot glowing bulb is transferring some of its heat to our hand held below it. The hot electric bulb cannot transfer its heat to our hand by conduction because air is a poor conductor of heat. What do you mean by poor conductor of heat? Materials which does not allow the heat to pass through it easily. So we had learned that air is a poor conductor of heat. The hot bulb also cannot transfer its heat to our hand by convection because the convection currents of air always carry heat in the upward direction, as we have seen in case of fluid, either in the liquid or in the gas. But our hand is held below the bulb. The hot electric bulb transfers its heat to our hand held below it by the process called radiation. All the hot objects can transfer heat by radiation. What is the reason? Why does it happen? Every hot object emits means gives out invisible heat rays in all directions. These heat rays carry heat energy. When these heat rays fall on a cold object, the cold object receives heat energy and gets heated. In this way, heat energy is transferred from hot object to cold object by means of heat rays. As we had discussed earlier also, heat is always transfer from hotter object to colder object. Method of transfer of heat energy by heat rays is called radiation. Heat can be transferred from a hot body to a cold body by radiation even if there is no material medium like solid, liquid or as between them. Radiation is the transfer of heat energy from a hot body to a cold body by means of heat rays without any material medium between them. So, what is radiation? Radiation is the transfer of heat energy from a hot body to a cold body by means of heat rays without any medium present without any medium between them. What are the examples of radiation? Can you give some example? Example of radiation is the transfer of heat energy of the sun to the earth. When we come out in the sunshine, we feel hot. Hot. How do we feel? We feel hot. This means that the heat from the sun is being transferred to us, which makes us feel hot. Heat from the sun reach on the earth. The sun is very far away from the earth. As you all know, it is not near. It is very far away from the earth, and there is mainly empty space. That is vacuum. What do you mean by vacuum? It is empty. Nothing is there. No air, nothing. Between the sun and the earth. Heat from the sun cannot reach the earth by conduction or convection because both these processes require a material medium like solid, liquid or gas to transfer heat. They cannot take place in empty space or vacuum. Heat from the sun reaches on the earth by the process of radiation. The sun is an extremely hot object. The sun emits heat radiation or heat rays in all directions. These heat radiation travel through vacuum between the sun and the earth at a very high speed and reaches on the earth. When the sun's radiations fall on the earth and its objects, they receive heat energy and hence get heated. The invisible heat rays which transfer heat by radiation are called infrared rays. What they are called? They are called as infrared rays. What are infrared rays? The invisible heat rays which transfer heat by radiation are called infrared ray. In our day-to-day life, we have many situations where heat is transferred by radiation through a medium called air. Can you give some examples or can you tell me the situations when the heat is transferred by radiation? Where you can see when we stand next to a burning fire, we can feel the heat of the fire falling on our face. Have you ever felt this? If you are standing next to a burning fire, what do you feel? You feel the heat of the fire falling on your face? Means the heat is transferred from the fire to your face by the process of radiation. Is there any medium between you and the fire? No. So it is falling directly to your face. Second example, when suppose if you sit in front of a room heater, if you are sitting in front of a room heater, what do you get? You get heat directly by the process of radiation. Next situation, a hot utensil kept away from the flame cools down by transferring its heat to the surrounding by radiation. Someday you might have seen hot utensils when we take it down from the gas, and when we keep it, after some times what happen? It cools down. How does it cool down? It cools down by transferring its heat to the surrounding by a process called radiation. Now, one more situation, see, depending on the temperature of surrounding, our body too gives heat to the surrounding or receives heat from the surrounding by radiation. So, in some situation, in these situations, in your day-to-day life, you can feel the radiation. Absorbers of heat radiation. The amount of heat which an object can absorb by radiation depends on the color of the object. On which, what it depends? It depends on the color of the object. The objects having dark colors absorb more heat radiations than the object having light color. Let us see one activity. We will do the one activity and then we will try to see this. What we will do, we take a black painted tin can and a white tin can of the same size and place them separately. Pour equal amounts of water in both the tin cans and fix thermometers. The initial temperature of water in both the tin cans are noted. We place both the tin cans in bright sunshine for 1 hour. The heat radiations of sun will fall equally on both the tin cans. After 1 hour, what do we know? After 1 hour, we note down the temperatures of water in both the tin cans again. What we will find? What we will find? We'll find that water in black tin can is at a higher temperature than in white tin can. Since the temperature of water in black tin can is higher, what does it show? It shows that the black colored tin can has absorbed more heat of the sun, and the lower temperature of water in the white tin can. What does it show? It shows that the white colored tin can absorbs less heat from the sun. A black object absorbs more heat radiation than a white object. Since the black object is a good absorber of heat radiation, it also means that a black object is a bad reflector of heat radiations. Since a white object is a poor absorber of heat radiation, it means that a white object is a good reflector of heat radiations. Emitters of heat radiation. The amount of heat which a hot object can give out by radiation also depends on the color of the object. The hot objects having dark colors emit more heat radiations than the hot objects having light colors. The objects having dark colors are better emitters of heat than objects having light color or on their surfaces. For this, to understand this, we'll see one activity. For this activity, we take a black tin can and a white tin can of the same size. These tin cans are placed on a wooden blocks separately and kept in a shady place inside a room. Both the tin cans are filled with the same hot water. What the temperature of the water will be same for both. We note the initial temperatures of hot water in both the tin cans. Their initial temperatures are exactly equal. Allow both the tin cans to stand for 10 minutes. After 10 minutes, note the temperatures of water in both the tin cans again. What you will find? We will find that the water in black tin can is at a lower temperature than the water in white tin can. This means that the black colored tin can has lost heat faster than the white colored tin can. Thus, a black object is a better emitter of heat. On the other hand, the higher temperature of water in white tin can shows that the white colored tin can has lost heat slowly. Thus, a white object is a poor emitter of heat. Dark colored objects absorb heat better and also emit heat better than light colored objects. Dark colored objects are poor reflector of heat, but light colored objects are good reflectors of heat. Now, importance of colors of object in everyday life. We'll see some examples which will show the importance of colors of objects in our day-to-day life. Now, we use dark colored objects where we want to absorb more heat and light colored object where less heat is desired. Color of clothes. People prefer to wear white clothes or light colored clothes in the hot summer days. Why? Why do people prefer to wear white clothes or the light colored clothes in the hot summer days? Because white clothes or light colored clothes absorb less heat from the sun. White clothes or light colored clothes reflect most of the sun's heat rays which fall on them and keep us cool and comfortable in hot weather. That's why people prefer to wear light colored clothes or white clothes during the summer. Have you understood? Now, people prefer to wear dark colored clothes in the cold winter days. In the cold winter days, we prefer dark colored clothes. Why? What is the reason? Why do we prefer dark colored clothes in the cold winter days? This is because dark colored clothes absorb more heat rays from the sun and keep us warm in winter season. This is the reason why do we prefer dark colored clothes during the winter. Now see, if you'll see the example of color of houses. The houses in hot sunny countries are usually painted of which color? White or with light colors from outside. Now why they are painted with light colors from outside? Because a house painted white or with light colors absorb very little sun's heat rays. It reflects most of the sun's heat rays. This keeps the house cool in the hot days of summer. The next example, solar cooker and solar water heater. The box of solar cooker. Have you ever seen? How many of you are having? Those who are having, they might have seen this. The box of solar cooker and solar water heater is painted of which color? It is painted with black from inside. This is why it is painted black from inside. This is because a black surface is a very good absorber of heat and it will absorb maximum heat radiations coming from the sun. So quickly we'll revise what we have studied today. We have studied about the land bridge and sea bridge, then absorbers of heat radiation, emitters of heat radiations, then colors of clothes.
Welcome to the lesson on what causes wind. In this video, we'll be focusing on sea and land breezes. The great thing about this lesson is that it draws upon each of the units we've covered so far this year. The main areas will include heat transfer, differential heating, density, convection, and air pressure. So let's get started and break some wind. Now the first thing we're going to need is a source of energy. So we're going to go ahead and put the sun right up there in the sky. Now, one thing we've learned about the way the sun heats the earth is that it does not heat the earth evenly. The earth's surface is made up of many different types of materials, and we have investigated how it heats 4 main earth materials. That would be sand, soil, air, and water. And most of those are going to come into play in this animation. First of all, let's go ahead and get a land source. And we're also going to need a water source. So we're going to go ahead and put the sea out there on the right-hand side. Now, we have learned from our investigation that land, which would be like sand or soil, heats up faster than water. Water has a higher heat capacity, so it takes longer to heat up. So in the course of a day, the land will be hotter than the sea. And you can always refer back to a life experience. If you've ever gone to the beach and you've walked across that hot sand, and as soon as you get to the water's temperature is much different than the beach temperatures. So that would mean by conduction, the air over the land would be warmer than the air over the sea. So warm air is right over the land, cool air right over the sea. Now, instantaneously, you should see that we have 2 different temperatures of air. And from prior knowledge, we've learned about density. And warm air does things differently than cool air particles. Warm air particles become less dense, and less dense particles will float or rise into the atmosphere. And oppositely, cool air becomes more dense and will sink. So you're going to have warm rising air over the land, but you will have cool air sinking over the ocean, or in this case labeled the sea. All right. Already at this glance, you should see a convection cell has formed. All right, a convection cell is essentially a cycle of moving air. And we're trying to prove and understand what causes wind. Well, we just got it already. It's right there. But let's add a few more components just to kind of tie this all together in a wonderful package. Since warm air is leaving the area over the land, that would create less pressure on the land. You see how the arrow is going away from the land? That would take air particles away. Therefore, there'd be less pressure pushing down on the land. But if you look over on the right-hand side where the cool air is sinking, and that arrow is drawing air particles down and pushing on the sea. That creates 2 different areas of pressure. That means low pressure is existing over the land, again, because the warm air is leaving that spot. And across the sea, there's an area of high pressure. That air is sinking and pushing down on that area over the sea. There you've got it. The rule is high pressure air always moves towards low pressure air. Air will move wherever there's a space. And since there's been a space created over the land, air will gradually just naturally push its way over there. And that's what wind is. When air is being moved in large quantities across the surface or in the atmosphere. So since we have a high pressure area over the sea, a low pressure area over the land, the rule is high pressure air always moves towards low pressure air. And now we have a movement, wind, moving from the sea over to the land. We name it a sea breeze because the rule is you name a breeze or a wind by where it originated from, where it came from. In other words, where is the high pressure? In this case, because the high pressure is over the sea and the air is coming towards the land, we name it a sea breeze. And you can see the collection of all your previous instruction kind of pulling together into this picture. So, there we have a sea breeze, but there's also such a thing as a land breeze. In order for a land breeze to work, the pressure over the land would have to be higher than over the sea. The entire cycle would have to go the complete opposite direction. But based on our picture, how is that possible? So I'm going to take a moment here and think about it. And the video is going to be paused for just a second and have a discussion. What factor would need to change in order for this cycle to go the other direction? In order for the wind to go the other direction, one important factor had to change, and that is it had to happen at night. The reason why it has to happen at night for the cycle to go the other direction is again linked back to our investigation when we heated the earth materials. After we turned off the heat lamp, we allowed the materials to cool off, and we noticed that the land substances, the sand and the soil, drop temperatures much more quickly than the water. That's because water has a high heat capacity. Not only does it take more energy for it to heat up, once it does heat up, it takes a lot of time, a lot of energy for it to cool off. Therefore, it will remain warmer longer, but the land temperatures will drop quicker. And that's the only factor that had to change. So, since that happens, and at night the land would be cooler than the sea temperatures, by conduction, we would have two different temperature air. Warm air would be over the sea, and cool air would now be over the land. You can see already that's enough to cause the cycle to go the other direction. Warm air rises, and cool air sinks. And just as before, if warm air is leaving an area, that area has less pressure than it did before. Which then, of course, also means that as cold air is sinking over an area, more pressure is added to that area, because you can see the arrow is pushing down over the land now. So now, high pressure over the land. And of course, high pressure air always moves towards low pressure air. So now we have not a sea breeze, because it's not originating from the sea. The high pressure is now over the land. And since the air is moving across the land toward the sea, it's called a land breeze. Well, that's the entire picture. So the next time you wonder how wind forms, you'll be able to blow right through it.